So welcome you to today's lecture. So last couple of lectures, we were discussing the notion of sufficiency. And the notion of sufficiency is about reduction of the data. Because your data at hand may be very huge. And you may like to structure it, or you may like to summarize it by getting rid of all the irrelevant or redundant information. So that leads to the notion of sufficiency. And we define what do we mean by a sufficient statistic. The definition is in terms of a conditional distribution, which says that a statistic is sufficient if the conditional distribution of x given t does not depend on the unknown distribution, the unknown parameter. Then we developed a criteria through which you can determine a sufficient statistic. For example, we saw that whole sample is always sufficient. So if there are more than one sufficient statistic, a basic question to ask is which sufficient statistic to use. So if you have any questions from the last lectures, you may ask them today or now. So if there are no questions, let me move further. So let me now do an example which illustrates that sufficient statistic may not always provide substantial reduction to the data. So the example which says that sufficient statistic may not always provide substantial reduction in data. Now we saw a few examples where through sufficient statistic, n-dimensional data x1, x2, xn can be reduced to a one-dimensional data like x bar or summation xi. But that may not be the case always, as the following example illustrates. So suppose I have a random sample x1, x2, xn, which is coming from a distribution f, which is unknown to me. What is at the best known to me is that f is absolutely continuous. So my f could be any distribution which is absolutely continuous. And I know that my sample is coming from any such distribution. So it is in certain sense, I'm dealing with the non-parametric setup. There is no parameter over here. The functional form of f is not known. Now suppose that MF is the common PDF of x. Because it is a random sample, so each of them would have the same PDF. Let me call the common PDF as n. Let xi is the ith smallest of x1, x2, xn. So that this x1 less than or equal to x2 less than or equal to xn or the order statistics. Then if I look at the joint PDF of x1, x2, xn, that is same as product of marginals, so product I is equal to 1 to n, each of them has the same PDF MF, so MFXN. Now note that since MF is same, this is same as MF of x1, MF of x2, and finally MF of xn. Now since this MF is same, I can always rearrange them in such a way such that wherever the argument is smallest one, I keep that as first. This can always be written as MF of x1. Then I keep MF of x2, and so on, finally, MF of xn. Now, when I'm considering this product, because x1, x2, xn are nothing but order statistic, So as a set, x1, x2, xn is same as a set of order statistics. What is happening over here? Here also each of mfxi is multiplied because as a set, x1, x2, xn is same as x1, x2, xn. And here also each of mfxi is multiplied. So that means they are same. So this can be written as product I is equal to 1 to n mfxn. So by factorization theorem, I can take this as my psi f of x1, x2, xn multiplied by 1, which I take as hx. So my joint PDF can be written as a factor of the product of two functions. One does not depend on f. The second factor which depends on f, and it depends on x1, x2, xn only through the order statistics x1, x2, xn. So this implies that T of x1, x2, xn is sufficient for f belonging to P. If I look at this statistic, this also has n dimensions. So it doesn't help us in a big way in deducing the data. So a sufficient statistics may not always be in a position to give you a substantial reduction in the data. Now let's consider a few examples. Let x1, x2, xn be a random sample from normal theta sigma square, where sigma is known. So only unknown parameter is theta, so that x bar is sufficient for theta. Now this is not very difficult to see because this we have seen. If I have to see f theta x, 1 by sigma root 2 pi, because of the random sample, it becomes 1/2 sigma pi to power n, e to power minus 1 by 2 sigma square, then summation xi minus theta whole square, so summation xi square minus 2 theta summation xi plus n theta square. Note that here sigma is known, so this can be consumed in H. E to power minus summation xi square by 2 sigma square has no unknown parameter because sigma is known. So this can also be consumed in H. Then you have e to power 2 theta summation xi. Here theta and summation xi cannot be separated out. So this can be written as a function of theta and xi. And e to power minus n theta square by 2 sigma square, that can also be a part of this function. So this can always be written as psi of theta, xi. What is my psi theta xi? Psi theta xi could be e to power minus 1 by 2 sigma square into minus 2 theta xi plus n theta square. What is my hx? 1 by sigma root 2 pi to power n into e to power minus sigma xi square by 2 sigma square. So by factorization theorem, now summation xi becomes sufficient. Now if summation xi is sufficient, your x bar is a one-to-one function of summation xi, so your x bar is also sufficient. Now let's look at x1, x2, xn is a random sample from normal 0 sigma square using definition so that Tx is sufficient for sigma square. So using definition, that means you have to show that the distribution of x1, x2 given t is equal to t, that means x1 square plus x2 square is equal to t. This does not depend on theta. Now one can show it to many. It means one way is to convert this into polar coordinates. You can take x1 as r cos theta and x2 as r sin theta. Then what you have to show is the distribution of r cos theta, r sin theta, given x1 square plus x2 square is r square, right? Given that r square is equal to t, this does not depend on sigma square. Now that is very easy to see. You can see that if I put a transformation x1 is equal to r cos theta and x2 is equal to r sin theta, then r and theta are independently distributed. And the distribution of theta is uniform 0 to pi. So r and t are independent, so this would be same as distribution of cos theta given r. That would only play the role over here. Because theta and r are independent. So this unconditional distribution would be same as, so this would have a same distribution as r square is t, so that means r is root t. So root t cos theta and root t sin theta. Why? Because theta and r would be independent. That you can prove very easily. You might have done it many times at your bachelor's level. Otherwise, also you can do it. You have to find a Jacobian and then see the joint PDF of r and theta. And distribution of theta, you know, is uniform 0 to pi. So this distribution is not going to depend on unknown sigma square because it is uniform 0 to pi. Similarly, now let x1, x2, xn be a random sample from normal 0 sigma square using definition so that tx equal to summation xi square is sufficient sigma. So it is kind of a generalization of the part A. Part A, I consider the polar coordinates. For the n case, you consider the spherical coordinates. So you have to make n transformation x1 is equal to r cos theta 1, cos theta 2, and so on. And then you can do exactly the same. So try to do this exercise. Let us consider another example. Suppose you have x1, x2, xn random sample from exponential mu sigma. So this is the density. My theta is mu sigma. Both are unknown. Using definition, so that x1 and summation xi is sufficient for theta. Is x1 and summation xi minus x1 sufficient for theta? Now, one can use the factorization theorem because if one consider the joint PDF of x1, x2, xn, what will it turn out to be? Product I is equal to 1 to n on all this. So that is 1 by sigma to power n, e to power minus summation xi by sigma, and then e to power n mu by sigma, provided each xi is greater than or equal to mu. Each xi is greater than or equal to mu, that means minimum is greater than or equal to mu. x1. This can be because mu is unknown. So here I cannot separate out xi's from the parameters. So this can also be a part of psi theta. This will also be a function of psi theta x. This will also be a function of psi theta x. This will also be a function of psi theta x. So this can be written as psi of mu sigma. And then what are the statistics? Statistics which you are getting are x1 summation xi into hx. What is your hx? Hx is 1. And psi is basically this whole of this. So by factorization theorem, x1 and summation I is equal to 1 to n xi. But this quantity and this quantity are one-to-one functions. Why? Because if you know this, you can get this. How? Because the first coordinate is same. The second coordinate is here is from I is equal to 2 to n. So what you do is from here, second one, you subtract the first one, you get I is equal to 2 to 1. So you can get this from this. Similarly, you can get this from this because first coordinate is same. And how do you get this coordinate? It is the sum of the two coordinates over here. So you can get each of them from each other. So they are one-to-one functions. x1 summation xi sufficient. X1 summation I is equal to 2 to xi sufficient. And what about this? If I look at this quantity, this is same as x1 summation xi minus nx1. Actually, this quantity is same as x1 because here all the xi's are all have been summed. So you can write down this as summation I is equal to 1 to n. This quantity is same as this quantity. This is sufficient, so this is sufficient. They and they are one-to-one function. So this is also sufficient. Now let us look at this quantity. Can I say that this quantity is a one-to-one function of this quantity? Here the first coordinate is same. Here the second coordinate I can get from this by taking the second coordinate here, subtracting n times the first coordinate. I can get this from this. Can I get this from this? Yes, the first coordinate is same. The second coordinate here is same as the second coordinate here plus n times the first coordinate over here. So you can get this also from this. So they are also one-to-one function. So if this is sufficient, this is also sufficient. What I've asked over here is to show that x1 and this quantity is sufficient using the first principle, using just the definition. What you have to do? You have to show that conditional distribution of x1, x2, xn, given that x1 is equal to t1 and summation I is equal to 2 to n xi is equal to t2, this conditional distribution does not depend on mu and sigma. So let me just leave it over here, try to show that this does not depend on mu and sigma. Now the reason I'm leaving these exercises to do it by definition will give you a lot of insight into how does the conditional distribution work. So far, you might have found out conditional distributions only in very trivial cases. All these examples would involve conditional distributions, which would be highly non-trivial. But they will give you a lot of insight about how to deal with conditional distribution. I would encourage all of you to do all these exercises from the definition itself. One is you can always use the factorization theorem. But wherever I am giving you problems, try to do them using conditional distribution also, so that x1, x2, xn, given the statistic, does not depend on the parameter. If you have any difficulties, we can always discuss them. Now let's consider another example where sigma is known. Now note that if sigma was known, then this can be consumed in hx. Sigma is known, so this can also be consumed in hx. So only quantity which has to be consumed in parameter and statistic is this later two part, which has only statistic x. If sigma is known, then x1 would be sufficient. Similarly, if mu is known, now note that if mu is known, then I can consume this part into hx and this part also in hx because mu is known. So the only part which has to be consumed in psi of theta and f or psi of theta and tx is this quantity 1 by sigma to the power n e to the power minus summation xi by sigma. So only statistic which is coming over here is summation xi. So if mu is known, summation xi is sufficient. This just follows using Factorization theorem. Now let's do this example. If x1, x2, xn are IID or random sample from uniform minus theta theta, find a sufficient statistic other than the trivial sufficient. Now note that the whole sample is always sufficient, which is always called trivial sufficient statistic. The whole sample is called a trivial sufficient statistic because the whole sample is always sufficient. So suppose you have this quantity. So if I look at the joint PDF of x1, x2, xn, it will be how much? Product I is equal to 1 to n of each of them. Each of them has a density 1 by theta, so 1 by 2 theta. So 1 by 2 theta to the power n. Then each xi greater than or equal to minus theta, and each xi less than or equal to theta. Each xi is greater than or equal to theta. That means the minimum is greater than or equal to minus theta. And each xi is less than or equal to also theta. So this is, so I can write down this as in terms of an indicator, because this would be this only when each xi is greater than or equal to theta. And then each, actually this can be written as, let me just write it down. No, it is 1 by 2 to the power theta n if mod of xi is less than or equal to theta. So the density becomes 1 by 2 to the power theta n, 2 theta to the power n. Xi lying between minus theta to theta, which is equivalent to saying that mod of xi is less than or equal to theta. Now this should happen for all I is equal to 1 to n. That means indicator that maximum of mod of x1, mod of xn. So what is happening this over? This can be written as psi of theta into tx, where hx is 1. And what is your tx? Tx is maximum of mod of x1, mod of. So what you get from here is that maximum of mod of x1, mod of x2, mod of xn. Now let's do another example where I'm dealing with a gamma density with PDF 1 power sigma to power alpha, gamma alpha, x to power alpha minus 1, e to power minus x by sigma, x greater than 0, alpha greater. So try to see what is the joint PDF of x1, x2, xn over here. Because it is a random sample, so it will be product I is equal to 1 to n of this with x replaced by xi. So it becomes 1 by gamma alpha to power n, sigma to power n alpha, product I is equal to 1 to n xi alpha minus 1, e to power minus summation xi by c. Now suppose both were unknown, then I cannot get rid of some product xi from here. Alpha is also unknown. Summation xi will also be there because sigma is unknown. So this whole quantity becomes my psi of theta, which is alpha and sigma, and product xi and summation. So in this case, my sufficient statistics would be product I is equal to 1 to n xi and summation x. Now suppose alpha was known and sigma is unknown. If alpha was known, then I can consume this quantity into hx. This does not have any unknown parameter. This can go into hx. So the remaining part which will have a parameter and statistic is this part and this part. So in this case, it will be psi of sigma summation xi. So in this case, sufficient statistic would be this quantity. Now, if sigma was known, then I can consume this into hx. this can be consumed into Hx. So only statistic which would be involved with the parameter which is alpha is product xi. So in this case, sufficient statistic would be product. So we saw various examples of Factorization theorem. Now, Factorization theorem suggests that for any given problem, there are numerous sufficient statistics. Because if there is one sufficient statistic, any one-to-one function of that is also a sufficient statistic. Not only that, if you know that T is sufficient and U is a function of T, and T is a function of U, this would imply that U is also sufficient. So one can get infinitely many sufficient statistics. Now the question is, among various available sufficient statistics, which one should be preferred over the others? Recall that the purpose of sufficient statistic was the reduction of the data. So I should prefer that sufficient statistic which gives me the maximum reduction. One which gives maximum reduction of the data. I should prefer that sufficient statistic. Now, since the purpose of using a sufficient statistic is summarization of data without loss of information about F, sufficient statistic which provides maximum reduction of data should be preferred. Such a sufficient statistic is called a minimal sufficient statistic.
Sir, hello.
Yeah, tell me.
Sir, in page 13, the example which you discussed at the end of page 13, sir, I have a question. I mean, using definition, if the parent distribution is discrete, then sir, we can start with a sentence like this: that probability x1 equals to x1, some xn up to xn equals to xn, given x1 equals to t, like this. And using some probabilistic calculations, we can ultimately come to an answer. And also in case of normal distributions, we have the idea of what the conditional distribution is. But sir, when the distribution is continuous, any other continuous distribution, if we want to use the definition, do we need to start with the CDF statement that x1 less than equals to x1, because there we cannot have a specific value for a particular random variable?
Yes, I think the best way is start with the CDF. So for example, let us look at this example, right? x1, x2, xn, and this you have to find a conditional PDF. So best way is, now note that what distributions you have studied so far are discrete or continuous, but there could be distributions other than discrete and continuous.
Yes, sir.
There could be a mixture of, they will have some weight on single points and some weight to the intervals, right? So there could be a mixed kind of a distribution.
Yes, sir.
No, so the best way to do that would be just look at the definition, which is probability that x1 less than or equal to x1, xn less than or equal to xn. Given that x1 is same as t1, and what is that? Summation I is equal to 2 to xi to n xi. That okay? Now this, by definition, this is same as limit h1 going to 0, h2 so you need to know the definition of a conditional distribution function. So this is a limit h1 going to 0, h2 going to 0 of probability that x1 less than or equal to x1, xn less than or equal to xn. Given that t1 minus h less than x1 less than or equal to t1, t2 minus h less than summation I is equal to 1, 2 to n xi. So you have to find this definition. You have to find this distribution function.
Okay, sir. Okay, sir. Understood.
Wherever
Okay.
continuous case are things, no, this is true for discrete as well as continuous. This is how the conditional distribution function is defined. Right?
Yes, sir.
So try to do this. Now, since you have raised this question, let me give you one. This is slightly complicated. Let me give you a simpler one. For that, let me just share my code. I'm happy that you asked this question because this is where many of the students have a problem. Not only that, a lot of PhD students even have problems in such a concept. So let us look at x1, x2, xn as IID uniform 0, 3. Now, in this case, one can show that PDF is 1 upon theta to the power n. Each xi greater than 0, that can be consumed in hx. And each xi less than or equal to theta, that means maximum less than theta. So Tx is equal to xn is sufficient, right? Suppose you have to show this using definition. Is that okay? So what do you have to show? You have to show that conditional distribution of x1, x2, xn given Tx does not depend on theta. Is that okay? What you have to show is probability that x1 less than or equal to x1, xn less than or equal to xn, given xn is equal to t, which by definition is same as limit h going to 0 of probability that 1 less than or equal to x1, xn less than or equal to xn. And now note that in discrete case, you could have directly written this as a probability xn is equal to t. But in continuous case, you cannot write down probability xn is equal to t because the event xn is equal to t has 0 probability. Because in continuous case, the value of a single point is always 0. So you cannot write down that. So how do you do this? You do it through t minus h less than xn less than equal to t. Now this is same as limit h going to 0. Now I can write down because this probability will not be 0. So probability x1 less than equal to x1. Xn less than equal to xn. Xn lies between t minus h to t divided by probability that t minus h less than xn less than equal to t. Now note that if I divide the denominator by h and I take limit h going to 0, what do I get? If I divide this quantity by h and take limit going to 0, that is fxn t minus fxn t minus h by h. That will give me a density of xn at the point t, right? So that limit one can easily get. So this is same as 1 upon f of xn t. Why? Because this divided by h to h, I know the limit, which is fxn t. And then limit h going to 0 of probability x1 less than equal to x. T minus h less than xn less than equal to. Divide. Is that okay? I've just divided by the h and that's it. Because that limit I can directly get. This already I know. Fxn t is n t to power n minus 1. What is fxn t? The uniform 0 case, you know the formula for fxn t. You can just see it is n t to power n minus 1 by theta to power n. I already know the density of RS order statistic. You can get it for uniform as. Now I try to look at this. Just this quantity. This is same as limit h going to 0 of probability that x1 less than equal to x1, xn less than equal to xn, and then xn less than equal to t minus probability that x1 less than equal to x1, xn less than equal to xn, and xn less than or equal to h and divided by h. Now xn is less than or equal to t, that means each xi is less than or equal to t. And here xn less than or equal to t minus h, that means each xi is less than or equal to t minus h. So that means x1 would be less than or equal to x1 as well as x1 would be less than or equal to t. So x1 would be less than or equal to maximum of x1 and t. So I can write down this as limit x0 t that x1 is less than or equal to maximum of x1t, x2 less than or equal to maximum of x2 and t, xn less than or equal to maximum of minus, just see what is happening over here. The first was that x1 less than or equal to x1, xn less than or equal to xn, then maximum less than or equal to t, that means each of them is less than or equal to t. That means x1 less than or equal to t, x2 less than or equal to t, xn less than or equal to t. So that means x1 would be less than or equal to maximum of x1t, xn would be less than or equal to maximum of x. Minus, same thing over here, except that the role of t has been taken by minus rho t that x1 less than or equal to maximum of x1t minus h, x2 less than or equal to maximum of x2
Sir, can you please explain why is this maximum, not minimum?
I'll tell you. Now suppose A is less than or equal to B as well as A is less than or equal to C, and a number A is less than or equal to B as well as the same number is less than or equal to C. What is that? What does that mean? What is the intersection? A is less than or equal to B, A is less than or equal to C. So this would be equivalent to saying that A is less than or equal to, yeah? So here it will be minimum, right? Just
Yes, sir,
1 second.
minimum.
Right? A less than or equal to, sorry, yeah. So you're right. You're right. That is what your doubt was? Yeah, it could be A is less than or equal to minimum of
Yes, sir.
E and C. Right? It could be minimum. Yes, you're right. X1 less than or equal to X1. Yeah, it will be minimum. All right. So what would be this quantity? Anyone? Now note that if any of the quantity, so this would be product, right? So this would be same as limit h going to 0 because xi's are independent. So this would be same as product I is equal to 1 to n f of minimum of xit minus product I is equal to 1 to n f of minimum of xi and t minus h by h. Is that okay? Now note that if any of xi was less than t, if any of the xi was bigger than t, right? If any xi was bigger than t, then what would happen? Then that term will give me here f of t minus f of t minus h. Is that okay? product I is equal to 1 to n fx e. Yeah, so you will get ft and then you will get a 0, right? If anyone, so each xi would be less than or equal to t. If each xi was less than t, then what happens? Then also you get here 0. So what it says is at least one of them has to be same as t. So this happens if so first case is when x1 is same as t, right? See, one way was you can directly seen from here that if xn was given to be t, I should find out only for these xi less than or equal to t. Because maximum is t, then each x1 should be less than or equal to t. Otherwise, this probability would be 0. So you should have already considered each xi is to be less than or equal to t. You should consider only density for that case. Each xi less than or equal to t, then in that case, this turns out to be limit h going to 0. Each xi is less than or equal to t, that means it becomes product I is equal to 1. Xi minus product I is equal to 1 to each xi is less than or equal to t. Right? F of minimum of all that, right? And I should only find for xi less than. Why? Because you can see from here, I can make my life simpler. Because xn is given, maximum is given to be t. So I should find the density only for when these x1 less than or equal to t, x2 less than or equal to t, and xn less than or equal to t. Right? So just try to see what happens in that case. Now, if each xi less than t, then what happens? If each xi was less than t, then because h is going to 0, t was over here, t minus h was over here, I can choose h sufficiently small so that t minus h is bigger than xi, and then I'll get this to be 0, if each xi was less than t. So the only situation arises when one of them is t and rest of them are less than or equal to t. Right? So if x1 is t, what does that becomes? It becomes f of x1. Product I is equal to 2 to n, f of xi minus f of t minus h, and product I is equal to 2 to n f of xi h. Now f of t, this is common, f of t minus h by h will give you a density. Similarly, x2 is equal to t and so on. So this was one way to do it using the distribution function. Now one can also find directly the PDF. What is the definition of a PDF? Let me call it one has to find directly the PDF. Let's look at f of x1, x2, xn t. That means xn is equal to t. This would have been limit each hi going to 0 and h going to 0, or probability that xi lies between xi minus hi to less than or equal to xi, because that is what. And then this for I is equal to 1 to n, and then xn lies between t minus h to t. You could have done this way also, same as limit hi going to 0, So I have left it, you just try to complete it, otherwise we can again discuss it tomorrow if you're not able to do it, right? I've given you a hint. It's slightly, as you must have seen, it's a non-trivial exercise. So this would have become probability that xi lies between xi minus hi less than or equal to xi, I is equal to 1 n, and each x, by the same logic, this could have gone over here, then xn less than or equal to t minus probability that x minus hi less than xi less than or equal to xi less than or equal to t minus h. Actually, there should be divided by h1, h2, hn also. You're considering the density of xi. This is a definition, right? h1, h2. Now, this is same as limit hi going to 0, h going to 0. You have to just be a little bit careful. Now, here xn less than or equal to t means each of them is less than or equal to t. This is same as, so everywhere it would be xi less than or equal to t would come. So product I is equal to 1 to n of f of maximum of I and t minus product, sorry, minus f of xi minus hi. That is this quantity. Minus, same thing over here, product I is equal to 1 to n. This would be f of each is less than or equal to xi, then xn less than or equal to t minus h. Means each of them is less than or equal to t minus h. So it will be again minimum, right? Not maximum. Of minimum of I and t minus h and minus f of divided by 1h. Then, of course, this density would also come over here, right? Probability that t minus h less than xn. I divided by h, I can make it a density. So this h would come over here, and this would come over f. Now you have to find out this quantity. Right? Just try to play around with this, and then what you would see is if x1 is t, then it will be 1 by n. Right? xi could be anything. And so on, if x1 is less than or equal. So try to find it out. Let me have just given you enough hint. Try to find it out, otherwise we may continue with this tomorrow's tutorial, because I'm just almost, I've finished the half of the lecture on this. Do you have any doubt in this? How to proceed further?
So can you explain the last line a little bit?
Which one?
The last line. There is
So
the
you
f
see,
of product
so
of f minimum of that
yeah,
thing.
so first of all, I think it's very important that you understand what is a definition of a conditional distribution, right? Suppose x and t, first I consider two random variables, real variable, x, t are two random. Right? PDF or PMF, because it can be continuous, discrete, it can be neither continuous nor of x given t is equal to t, how it is defined. First of all, you have to understand that. So that is defined as f of x given t is equal to t. The point x has limit h going to 0 of probability that, because you're talking about density of x, so x minus h less than x then equal to x, and given that t is equal to. That is how it is, and divided by h. That is the first step, right? Because it would be, what would be this? This would be nothing but fx given t is equal to t minus fx x minus h given t is equal to t divided by. That is a usual definition of a density, right? Because you define this is limit h going to 0, h minus density exists. This is same as limit h going to 0. And then I can convert this probability also in terms of x minus h less than x less than equal to x, given that t lies between t minus k less than equal to t, right? And divided by h. Now you can play around. So these are definitions. So you have to play around with this definition, right? These are one way. Now if I have to find a distribution function of x given, right? How do you do this? So you find it out f of x t, which is same as probability x less than or equal to x. See, the problem of directly going to the density is that you are assuming that density exists, which you are not sure. Density means because you are not sure that this conditional distribution is a continuous distribution. If you knew that conditional distribution is a continuous distribution, then you would have proceeded like this. When you are not sure, you would like to go through a distribution function. F of x given t is equal to t, x is same as probability x less than or equal to x given t is equal to t, which is same as limit h going to 0 of probability that x less than or equal to x given t lies between t minus h. This holds for discrete as well as continuous. Now you can continue the way you want, right? Now what was happening now, if there were n variables, then in place of x less than or equal to x, you get a x1 less than or equal to x1, x2 less than or equal to x2, xn less than or equal to xn. Similarly, here there can be more than one piece, and in place of one h, multiple h would come over. Right? Now, what was happening in your case was you are interested in finding out, because you are trying to find out the conditional distribution of x1, x2, xn. It is safe because I do not know given xn is equal to, that is what you are, and you're trying to find out. So this, by definition, is same as limit h going to 0. I would say that you start with this rather than going to a density, because you do not know whether the density exists or not. So this is same as limit h going to 0, probability that x1 less than or equal to x1. The way I was proceeding earlier, and then xn lies with t minus t less than or equal to t. Now note that it is very obvious that this distribution is not going to be continuous, because given xn is equal to t, you know that 1 of x1 would be same as t. And try to do this then the way I have suggested. What I would suggest is today you spend doing this of your own, and then tomorrow tutorials I can take up this problem along with other problems in your assignment number 1. So try to do this homework number 1, and then we can discuss it tomorrow. But I would suggest that try to devote some time very seriously on this conditional distribution, because that is very important to understand whether you are going for a PhD in statistics or a data science, or even if you are going for a job anywhere, you should know these fundamentals. That's all I have, because I have already taken 4 minutes extra. So we'll discuss it again tomorrow, because this is one of the important concepts. I expect you to learn it with full sincerity. So anyone having any other doubt? So if there are no doubts, let me just disperse. Today also I see there are only 26 students. This is despite my caution yesterday. People are not coming. It means they don't have any respect, right, for a teacher. They don't have any. Just convey it to me. I'm taking it very serious. If they don't show any respect towards me, should they expect any respect from my side? This is highly unacceptable. Please convey it to your friends. Any questions anybody has? Okay, there are no questions. Please, you may leave. I would wait for everybody to leave. If anybody wants to stay back and ask questions, one may do so.
Sir?
Yeah.
Sir, just a clarification. So, in the assignment that you have given in question number 2, so there is a variable t given x bar n by Sn. Sir, does x bar n refer to x bar or is it xn? Like x bar n isn't given anywhere in the question.
Let me just check.
Okay, sir.
Let's come up with that. Which question you are saying? Question number 2, right?
Yes, sir. Question 2.
So what is your problem?
Sir, the variable t, it's given x bar n by Sn.
Right.
So x bar n refers to x bar means
X bar,
mean of
yeah.
x.
X bar, yeah. X bar means I have introduced n just to emphasize that it is based on a sample size n. So x bar n is 1 upon n summation xi. So let me.
Sir, it's the same x bar as which one is used in Sn square, right?
It is the same x bar.
Okay. Thank you, sir.
Any other doubt? Any other doubt? Anybody else? Okay. What about Sagun? Any doubts you have? Yeah, ask me. Do you have any doubts? Oh, your mic is not working? Can you write something in the chat box? And I can try to see if I can answer your question. Page 15 of today's lecture, right? Let me see. Page 15. Yeah, so what is the doubt? In fact, I could not start with page 15 today. if U is sufficient statistic, then V is a function of U, or a U is a function of V. Does this make any difference? Yes, it makes a difference. Why? Because no, what is your, I still didn't get your question precisely. If U is a sufficient statistics, then if V is a function of U or U is a function of V, so that means it doesn't have anything to do with sufficient statistics. Your question is, what is the difference between when I say that T is a function of U and then U is a function of T? What is the difference between the two? Is that your question? So you see, let me just okay, so let me just check if I can. Yeah. So you see, when I say that T is a function of U, what it means is, given, so that means T depends on U. So that means given the value of U, I can find T is a function of U means given the value of U, I can find. Not otherwise. Not necessarily otherwise. For example, X bar square is a function of X bar. Because given X bar, you can find X bar square. But X bar is not a function of. Why? Because given X bar square, you cannot find X bar. Because if X bar square is given to be 2, your X bar could be, or X bar square is given to be 4, then X bar can be plus 2 or minus 2. So you cannot find X bar if you are given X bar, unless you know that X bar is positive. So what does sufficient statistics says is, if T is sufficient, so if T is sufficient and T is a function of U, then U is also sufficient. Way to understand this would be, T is sufficient means if I know the value of T, that is good enough. But you're also given that T is a function of U. So that means if U is known, you know, knowing T is sufficient. So if you know U, you know T, and knowing T is sufficient, so U would also be sufficient, not the other way. Right? For example, let us look at x1, x2, xn, IID, normal, theta 1. X bar is sufficient. If X bar is sufficient, I cannot say X bar square is sufficient. Right? Because what it says is knowing X bar is enough. But knowing X bar square may not be enough, because knowing X bar square cannot give me X bar. But if x bar is sufficient, e power x bar is sufficient. Why? Because if you know e to power x bar, you know x bar. Because x bar is a function of e to power x bar. Why x bar is a function of e to power x bar? X bar is same as log of e to power x bar. But which is sufficient, and this sufficient statistic itself is a function of e to power x bar. So e to power x bar would also be sufficient. But x bar square will not be sufficient, because knowing x bar square, you cannot get x bar. Does that clarify your doubt, or? Let me see what is there. Okay. That's all you have for today, or you want to discuss something more? Okay, that's all. Have a great day then.